Hey guys, it's Andy here, and today I just wanted to make a video, show you a homemade furnace. It says Portage and Main, but it's not. Never buy a Portage and Main furnace, they're terrible. So I just wanted to explain this quickly, and if you have any questions, just ask me after you watch the video, since some of them might be answered in this video. Here's the blower for it. It's into the middle of the furnace. I'll open it up and explain that in a minute. But it just uses a simple servo motor, and basically that's just a flap, right? It's, for the blower, it's just a fan and a hole, and then just moves. That's how simple it is. And there's two different settings, one for summer, one for winter, since this is used for a business. And the door also has the antifreeze going through it to increase the efficiency. As you can see, there's valves in case you have to replace the hoses. This design is okay for closing the door, but there's two of these furnaces, so I'll show you the other one after. But this one's very simple. You can pretty much see what it does. So, you can't see the blower. It's down inside in the middle, but it's just a tube with a little curve on it so stuff can't block it off. But there's also high quality bricks in there, and that's very important. You can't get cheap Chinese bricks. They don't last, they crack and shatter. So it's good to know. Alright, that's just a fan to suck the air out, so the room doesn't fill up with smoke, and it's just drywall covered box pretty much that just leads to the outside. Very simple. And the on-off for the blower is right here. Here, turn on. And yeah, it's very simple. And this is all the piping. It goes to different buildings. For just building a normal house, you don't need this many. Like, there's 3 pumps, I believe, in this system. And this is a sensor, detects the temperature of the pipe just by touching it, and it'll redirect the flow based off of that. So if it's too cold or the furnace went out, then it'll only circulate water through the furnace and through the reservoir here until it gets up to temperature, and then it'll redirect the flow and start heating the buildings. Having a hot water tank as a reservoir is extremely important in having a high efficiency furnace. One of the biggest problems with furnaces that are made is the plenum, the distance or the diameter or volume of water in the furnace. So there's the main casing, then the outer shell, and in the middle of that is your antifreeze, and that heats up and then is pumped to circulate throughout your building. Now, if you have too much of a distance, then you have too much volume, and if it's cold, it'll suck the energy right out and kill the furnace. So you don't want too much space in there, but you always have to have a pump running and dumping the water into the reservoir and then sucking it through and recycling it. And if the power goes out, then the pump turns off, and then it'll start boiling over. So that's why in the other furnace we have a modified sine wave inverter and a battery backup, and a relay that I made to make a UPS for dirt cheap. So this is pretty simple. You can see the motor. Just a simple fan, and that's it. And sensors Just detects the temperature and then opens or closes and turns on or off the fan. Let's see. These ones, they have their high and low settings. It's pretty simple. I believe these are all standard kind of stuff that's on all furnaces like this. Open this up. That's nice. Look at that. And it's a very, very simple design. It's home built. It took 300 hours of welding and a few $1,000s in metal and pipe and brick to make the stove alone and get the hot water tank. So you can probably just get those used if possible. So using dry wood helps a lot. This floor is all heated. It's cement with pretty much the same, I don't know, I don't think we have any of it. Yeah, this orange stuff here, we have it just coiled in the floor in the concrete, so it's heated floors. But I'll show you the next one. So this is just to give you an idea of how much snow we had. The furnaces, we have 2 of them, they worked extremely well. It was minus 30, sometimes 3 days in a row. Most of January and February was minus 20s and 30s, but the snow used to be up to the top of the roof, but now that spring's coming, a lot of it's melted, but a lot of snow. So this is the first furnace that was ever built. You can see there's the same fan as before, same design. This one I made it so when you're filling, the fan will be on and the blower down here will be off. But I also had a bypass to that right here. So we were doing some welding, so we can just put that back to normal. And so here's this blower. And same thing, it's very simple. It's just a wire. It's pretty rickety, but whatever. It works really well, I assure you. And just a servo motor and a transformer for it. So anyways, all this is like turns it on. So this plug here and the blower. So basically, when the blower is off, the servo motor goes down to the off position and just plugs the hole, more or less. And then when the blower turns on after a certain temperature, this motor will go up and open this up and the fan will turn on. So you have to cover it when it's not on because you need to cover the blower. I don't know, it makes sense if you understand this stuff. And then this is just, it's got a high, low setting for basically putting electricity to this wire here that goes here that turns them all on. And the sensor is right here, right in the back of it. So very simple. So this one, the outside shell here, it's bowed a bit. As you can see a little bit of bowing. That was caused by the power went out and this pump right here turned off. So it just got so hot it boiled, and then the boiling turned to steam, so there was just steam, and then it just pushed it out a bit through pressure. So this was the first one that was built, and a few things are not necessary in it that could have been removed, like I think this, we didn't even need it, but whatever. Learning, and just pretty simple. Oh, I don't want to, there we go. Okay, so I'll have to open the thing up. So this is the other way that you can make your door, and I like it a lot better, but this one we have to put a stick in because we grind it off a little too much, so we're gonna have to weld a little piece of metal on there to fix that. Alright, so there she blows. Alright, sorry. Whoa. So that's the, you can see it's very basic, very simple. I think I need gloves. Alright, I had to put down the camera to close it back up again. But it's very basic. It's a very clean and efficient running furnace. Let's see. So there's a drain for the plenum, and the amount of antifreeze that's in the plenum in between the two, I don't know, shells, I guess. Between the shell and the firebox is not very much. I don't know the numbers. I'd have to put them up in the description. But you don't need very much as long as you have the hot water heater. And there were a lot of changes to it based off of learning experiences. There's a lot of ways to get rid of ash. And everything builds up. We have very little creosote buildup. The less creosote buildup you have, the more efficient you know your furnace is running at. So we have these two pumps, and then the main pump. This sensor here gives power to these two pumps. Basically, where is it? There we go. This is an automatic valve. It's all self-contained, there's no electronics, and when the temperature gets below a certain temperature, it diverts the flow and only has the antifreeze go from the furnace into the tank and then back to the furnace until it gets up to a higher temperature. Once it gets to that desired temperature, then it'll redirect the flow from this T-valve through the system, and that's also what this sensor does here. It gives power to these two pumps once there is the desired temperature. So that's pretty much how this one goes. There's a lot of drain valves and bypass valves and everything. Since this is just such a large system that heats multiple buildings, and like I said, we had a really harsh winter this year. But these furnaces did extremely well. Over here is the UPS backup that I built using a simple relay. This relay and a modified sine wave inverter. Each one of those pumps required less than 100 watts. This is 300 watts. For some reason it's not working, even though the motors don't give a surge. Which is odd. I gotta replace the battery. It was shot before we even started, but I just have it really simple. It's just a light switch basically to test out the UPS system. So there we go. And then immediately it goes to red. So that's because the battery's shot, that or the fuse is shot, but we don't have any problems with blackouts or brownouts, so it's not on the high priority list at the moment. We're more or less just working on all the other things we have going on. This is a oil furnace right here. It's just emergency backup only. Just there for looks pretty much. So this one, we have the blower at the very front of the furnace, as you can see, and it does not burn the wood as efficiently, not nearly efficiently enough. Really, the blower should have been in the center, just like the other one. So that's a very important key thing to note. And it's just a simple blower. There's nothing fancy about any of this stuff. So, yeah, and that's it. the bypass that I have to give power to the system. Yeah. And of course, this is all drywall. Drywall absorbs heat extremely well. We had a fire in the other furnace room a few years ago, and it was absolutely amazing how much heat that drywall sucked up. There was wood behind the drywall, plywood, and it looked absolutely brand new behind horribly burnt and charred away drywall. So like this stuff, it was absolutely undamaged. It should be covered in drywall, but it's not a huge concern. The fire was caused by a bucket of ashes that was too close to newspaper and kindling, so it's important to note, keep your tinder as far away from your wood stove as possible, and if you're cleaning out the ash, you immediately throw it out. You don't keep it in the building. So anyways, and yeah, if you have any questions, just let me know and I'll ask the guy who built this, and just thought I'd share it. It works extremely well, and honestly, if every furnace in every home that heats with wood was this efficient, we would save millions of trees a year. I don't know, like, trees are different diameters, so you could say millions, but at what diameter, right? So anyways, this thing's extremely good, and if you have a welder, welding up your own is really good. You just have to be really good at welding. I'll show you the welder we use. So this is the welder we use. It's extremely old, but it's very, very reliable. These things are really expensive if you can get your hands on it, just because of the sheer amount of copper inside them. So, see, it's just a Miller one. It works beautifully. We had problems with polarity. It was someone put the wiring in wrong. But once we had that fixed, it welds absolutely beautifully. It's a beast, it's huge, but it works extremely well. And yeah, if you ever see one of these, buy it, because it's worth a lot of money. I wonder what the... Yeah, there's a plate number. There you go. Just in case people ask. So yeah, that's it. Anyways, like, favorite, subscribe. Have a good day.